Hi everyone, my name is Ivan Nathan Parmenas, and today I am going to introduce to you my experiment about ImageNet classification with Python and Keras. So in today's presentation, I will divide it into three parts. The first is introduction, where I will briefly mention what computer vision is, how it works, its usage, real-world application, the experiment objectives, requirements, environments, and a brief introduction to what ImageNet is. Then I will describe the procedure of how I did this experiment, which I'll guide you through. And last is the result and demo, where I will show a result of the classified image and that has been run through the program, and I'll show a demonstration of the working program. We, we all must have heard and even experienced computer vision in any numbers of ways. It is one of the most powerful and compelling types of artificial intelligence. Early experiments in computer vision started in the 1950s, and it was first put to use commercially to distinguish between typed and handwritten text by the 1970s. Today, the field of computer vision has grown exponentially and has been able to surpass humans in some tasks related to detecting and labeling objects. So, how does computer vision works? Computer vision technology tends to mimic the way the human brain works. On a certain level, computer vision is all about pattern recognition. It focuses on creating digital systems that can process, analyze, and make sense of visual data in the same way that humans do. The concept of computer vision is also based on teaching computers to process an image at a pixel level and understand it. Technically, machines attempt to retrieve visual information, handles it, and interpret the results through special software algorithms. So here I'll describe the general steps of how computer vision works. The first step is millions of images are sent to the computer. Then the computer will interpret these images as pixels and each with their own set of color values. Then it will subject them to algorithms that let them analyze the colors in the photo, the shapes, the distances, and so on, so that it identifies a profile of what that image means. And lastly, it will then create a model of that image. Hence, if a particular image has a similar pattern to it, it can detect and identify the image. Here is an example of how computer processes these images. It is a picture of Abraham Lincoln. Each pixel's brightness in this image is represented by a single 8-bit number, ranging from 0 to 255. These images are what software sees when you input an image. This data is provided as an input to the computer vision algorithm that will be responsible for further analysis and decision making. Here are a few common tasks that computer vision systems can be used for. The first is object classification. The system parses visual content and classifies the object on a photo or video to the defined category. For example, the system can find a dog among all objects in the image. The second is object identification. The system parses visual content and identifies a particular object on a photo or video. For example, the system can find a specific dog among dogs in the image. And last is object tracking. The system processes video, finds the object that match search criteria, and track its movement. Some people may think that computer vision is something from the distant future, but in fact, it has already integrated into many areas of our life. Here are just a few notable examples of how we use this technology today. The first is content organization. Computer vision systems already help us organize our content in like photo album. The app has access to our photos collections and it automatically adds text to photos and allows us to browse a more structured collection of photographs. Second is facial recognition. This technology is used to match photos of people's face to their identities. This technology is integrated into major products that we use every day, like our phones and laptops, and it is a crucial technology for biometric authentication. Third is self-driving cars. Computer vision enables cars to make sense of their surroundings. A smart vehicle has a few cameras that capture videos from different angles and send those videos as an input signal to the computer vision software. The system then processes these videos in real time and detects objects like road marking, objects near the car, traffic lights, and etc. One of most notable examples of this application is the Tesla Autopilot. Fourth is augmented reality. Computer vision is the core element of augmented reality apps. This technology helps AR apps to detect physical objects, both surfaces and individual objects within a given physical space in real time, and use this information to place virtual objects within the physical environment. And last is health. Image information is a key element for diagnosis in medicine because it accounts for 90% of all medical data. Many diagnoses in health are based on image processing like X-rays and MRI. Computer vision proved its effectiveness during medical scan analysis, and for example, computer vision algorithms can detect diabetic retinopathy, the fastest growing cause of blindness. Computer vision can process pictures of the back of the eye and rate them for disease presence and severity. So, what is the objectives of our experiment? It is to study and demonstrate how to implement an image classification program using Keras and Python in a virtual machine using the Imagenet dataset. The requirements are to get familiar with Keras and Python programming in a virtual machine, then utilize one of the three Keras model networks, the VGG16, VGG19, or ResNet 50, to recognize common objects using the ImageNet datasets. The working environment will be using Oracle VM VirtualBox and Ubuntu 20.04 version as its operating system. But before we move on to the experiment procedure, I'd like to introduce to you what Imagenet is. So Imagenet is an image database organized according to the WordNet hierarchy, which is a large lexical database of English grouped into sets of cognitive synonyms, in which each node of the hierarchy is depicted by hundreds and thousands of images. In the context of computer vision and deep learning, we are referring to ImageNet Large-Scale Recognition Challenge. The goal of the image classification track in this challenge is to train a model that can classify an image into 1,000 separate categories using over 100,000 test images. The training dataset itself consists of approximately 1.2 million images. Now, once we have known what ImageNet is, we are ready to implement it in our experiment. The first thing to do is to create our virtual machine by downloading and installing Oracle VM VirtualBox 6.1.18 version from their website to our machine. While waiting for the setup to finish, we can download Ubuntu 20.04 LTS version from their website. Once VirtualBox is successfully installed in our computer, open it and click New to set up our Ubuntu virtual machine. In the dialog box, Name our virtual machine, specify the type and version. In this experiment, we'll name it Ubuntu 20.04 and the machine folder we'll locate it in local disk D, the type to Linux, version to Ubuntu 64-bit. Then click Next. Now we need to allocate memory size and virtual hard disk space. Accept the default Create Virtual Hard Drive Now. Then continue to accept the default VDI drive file type. Then change the storage type to fixed size to increase system's performance. Then now choose your desired virtual hard drive space. In this experiment, we will use 50 gigs to be allocated to avoid running out of space. Now click Create. Once our virtual machine is created, we are ready to mount our Ubuntu 20.04 into our virtual machine. We can select our virtual machine, then click on Settings, then on Storage, click on Empty under Controller IDE, then we click on this CD/DVD icon and choose your Ubuntu 20.04 ISO file that we have previously downloaded to be mounted. Then click OK to continue. Back to our Oracle VM VirtualBox Manager, click on our Ubuntu virtual machine and hit Start button. Wait for the machine to load and you shall see a welcoming screen. Then click on Install Ubuntu button. Ubuntu will ask a few questions such as your location, preferred keyboard layout, your name, passwords, and etc. Click Continue and wait until the installation is finished. After installation is finished, restart your virtual machine, and once you have finished restarting, on your Ubuntu desktop OS, we are ready to set up Python, Keras, and other libraries. With Ubuntu 20.04, Python 3 is pre-installed. Hence, we'll make sure our version is up to date. So to do this, we need to open Terminal in our Ubuntu. In Terminal, we can type sudo apt update to check for updates. And then after finish checking for updates, we can confirm those updates by typing this command. Once the process is complete, we can check our Python version by typing python3.v in our terminal. Then install pip, which will allow us to manage software packages for Python and install our venv virtual environment. With venv installed, we are ready to create our environment directory, and we can achieve this by typing mkdir environments in our terminal to create a new directory. Now, to access our environment directory, we just need to type cd environments, and then we are ready to create our virtual environment and activate it. Now we have access to our virtual environment. Once inside our virtual environment, we can install Opencv, but first we need to recheck for any updates. Then we can type pip install opencv-python. Then verify the installation. We can type python 3-c import cv2, then print cv2.version. Still inside our virtual environment, we are going to install a Python package used for numerical processing, then install Python's computer vision, image processing, machine learning libraries, TensorFlow, and Keras. Once all the libraries have been installed, we are ready to write some Python code to classify image contents. To start, we should create a new file and name it imagenet.py by using the command nano imagenet.py. In the text editor, we can start by importing our required Python and Keras packages. Then we need to construct the argument parser and parse our argument. We'll only need a single switch here, which is the path to our image. We then load the input image using the Keras helper utility from the disk while ensuring the image is resized to 224 by 244 pixels as required by the VGG16 network, then convert our pillow format image into a NumPy array. Now we can load our VGG16 network pre-trained on the Imagenet dataset. Once our network has been loaded and initialized, we can classify our image and predict class labels by calling the .predict method of our model. We'll loop over the prediction and display the rank 5 times. Next, we load the image via Opencv, draw the prediction on the image, and display the image on our screen. Now, as we have finished the code, we can exit the text editor by pressing Ctrl X on our keyboard and then press Y to confirm. Now, we go to Files and open the Environments directory folder, then right-click and click on New Folder and name it Images. Inside Images folder, we can copy or download any necessary images to be classified through the program. Once we have our desired images, we'll run the program from the terminal using our image, and in this example, we'll use puppy.jpg. Once we have run this command, the image will then pop up and show a label of its classification. And to exit the image, we can press 0 on the keyboard. This is an example of the image classification we did previously from the procedure. The program has successfully classified and identified the subject in the image as a golden retriever dog at 95.71% probability. Now, I am going to give you a demonstration of the working program. Now, I already have my Ubuntu virtual machine running from Oracle VM VirtualBox. To run our program, we first open terminal, then type cd environment, then activate our virtual environment. Once we have activated it, we can run our program by typing python imagenet.py --image, then images slash. Here we are going to use beer as our sample image. Then press enter. The first time we load the image, it will take some time. And as we can see here, the program has successfully classified our image as a beer of glass with 70.46% probability. To exit the image, we just need to press 0 on our keyboard. Now we'll use another image. Here we are going to use a book PNG image, and we'll see how the program classify this image. As we can see, the program classify our book PNG image as a pencil sharpener with a probability of 39.34%. Now, we'll try with another image. Let's try burger. Now, we can see that the program has successfully classified our image as cheeseburger at 65.72% probability. Hence, it can be concluded that our program has a higher accuracy when classifying JPEG images compared to PNG images. That's all for today's demonstration. Thank you for listening.